Today what we're going to be talking about are square root graphs. So let's get started. So when you are graphing square root function, and right here you can see we're going to graph this function f of x equals the square root of x. And what we're going to do is we're going to sketch it, but there's some important numbers you want to do. Since you have a radical here, you want to try to get perfect squares. So for your points, if you were to put a 1 under there, you're going to get square root of 1. That's not going to be very convenient to graph. So we want to try to get perfect squares under there, and that's why I chose the point 0, 1, 4, 9, 16. Those are all perfect squares and easy to plug into there. So we're going to go ahead and we're going to substitute in our points. So 0, so if we were to have square root of 0, well, that gives you 0 right here. If we were to square root of 1, that gives you 1 there. Square root of 4 gives you 2. Square root of 9 gives you 3. And the square root of 16, oops, that's a weird radical. Oh, hello. Square root of 16 gives you 4. And then so all I did was I plotted all of those points already on the graph for you. So you can see those points, and then I connected it. And then when you connect it, it is a curve, it's not a straight line. So here's some important things to note about this. The domain, which are your x values, if you notice you have a bracket, that's because it includes the point 0, but then it continues on into infinity. So your x's will always increase. So that's why we have there. Now for the range also is from 0 to infinity, because the y value, it's on 0, but then it continues to get higher and higher up as it continues on. So the interval for increase is from 0 to infinity, and that's just what you can see, the same thing as when it's going up. Now again, here's some key points here when you're doing a square root graph. You always want to try to get a perfect square. So for there, it can also, the next one would be like 16, and then 4, and so on and so forth from there. So those are some key points to graph. All right, so now go ahead and let's copy all of this down on your notes. And here it says the transformations for a square graph are just like the ones for the quadratics. So if you remember, quadratic graphs are y equals a times x minus h squared plus k. So this is your quadratic. And if you look, this is very similar, but instead now we have a radical. So that's the big difference. But some of the transformations that you're dealing with are very similar. So if a is negative, it's reflection over the x-axis. If a is greater than 1, then it's stretch or narrow. If a is between 0 and 1, it's to compress or widen. And then if x minus h, now remember I said it's really a minus a positive h, you're going to shift right. If it's x is positive, it's two negatives, so you're actually going to go left. And if k is positive, you're going to shift up. If k is negative, you're going to shift down. Now, instead of calling it a vertex, we're now going to call it an anchor point. So an anchor point is same thing as before as your vertex, it's HK. So like I said, all very similar. The main difference is you now have a radical instead of just parentheses squared. All right, so let's go ahead and let's look at some of this information. Go ahead and get this information on here. So again, translations, if h is negative, you go right. If h is positive, you shift left. So if you notice, I started here, I went left 2, and then I went down 3, and I ended up here. So I just rewrote this here from the graph. And then next, if you were to have a reflection, now notice before it's always been positive values because you want a positive value under here. If you have a negative value, then it's going to flip it. So, but notice the negative is going outside the radical. The negative is not inside the radical. So if you have a negative in front of the square root, it's actually going to go this way. So it flips it over the x-axis. Now, for vertical stretch or compression, this is similar, where if A is greater than 1, here's my example, 3x. If A is greater than 1, it's going to vertical stretch by a factor, like that, so it makes it a little bit like that. And if it's compressed, it's going to get flatter by a factor of A if it's between 0 and 1. And then this is just if A equals 1. And then now let's go ahead and let's identify transformation, anchor point, domain range from the parent graph. So if you look at number 1, and up here, whoops, I wrote the parent function. So if you notice, there's a 1 here, h is 0, k is 0. So this is the parent function. So if there's any difference here, then you know there's some type of transformation. So now let's look. Well, yep, I definitely have a plus 2. So remember, this is really minus a negative 2. So that means you're going left 2. This minus 3 means you're going down 3. And your anchor point, which is similar, which you can think of like your vertex, is going to be negative 2, 3. And then your domain is you're going to look at this. Your domain is going to include 2. And it's going to go from negative 2 to infinity. And remember, you covered around infinity because it continues on. Your range is going to go from negative 3, and it includes negative 3, all the way to positive infinity. And then your interval of increase is basically your x. So where does it go up from? Or your h, excuse me. So it's going to go from negative 2 all the way to infinity. And make sure you have a bracket there. So go ahead, get that copied down. And then here, this one's a little different because now this has negative 2 out front. And then you have your radical, you have your plus 1. But remember, it's really, minus a negative 1 from there. So let me try that again. Minus a negative 1, parentheses. And then you've got your plus 4. So this guy right here, it means it's a reflection over the x-axis. And then this means it's a stretch by 2. And like we said here, you're actually going left 1 and you're going to go up 4. So your anchor point, which is your h and k, that's negative 1, 4. So your domain, you're going to use your h, and that's going to include that, and it goes to infinity. And then your range, here's where it gets tricky. Notice you have a negative a. What happens is it flips the range. So before, we would have written this, but now, since it's a negative, we're actually going to go from negative infinity to 4. So because it flipped it over the x-axis, now we're changing the direction that it's going. So your x's are going to get more negative with this. All right, what you're going to do is you're going to complete those, and we can check those in class. And then now, let's go over graphing them. So the goal is you want to make a perfect square under the radical, because if you get a perfect square under here, it's going to make your points here a lot easier to plot. So let's go ahead. So what I did is I want to get what minus 3 equals 0. Well, we said if 3 minus 3 equals 0, that works there. And we said here we want to get a perfect square, so our next perfect square is 1. So we have to think 4 minus 3 equals 1, and that's why we chose 4 here. And then here, again, we're trying to get to another perfect square of 4, because notice 0, 1, 4. If we had more points, we would try to get to 9. So in this case, if we did 7 minus 3, we got 4, and the square root of 4 is 2. Now, go ahead and you can plot your points. And then connect. And your anchor point was right here. Your domain is your h value, so it's going to be 3 all the way to infinity. And then, so basically here all the way to infinity, your range is going to be your y values. So we're going to go up this way from 0 all the way up, because it's going to continue on and on and on. That was not a straight line. So that's the information you have there. You're going to go ahead, you're going to try number 2. Number 3 is a tricky one, because notice we have a negative. So we've got root x plus 1 minus 2. All right, so now let's look at our information. Again, we want a perfect square. So what number? We've got 0, 1, 4. If we had more, it would have been 9, and then you would have been 16, so on and so forth. So to get 0, we would have to make x -1, and so that would make y -2. Oops, sorry. And then to get to the next perfect square, which is 1, we need to make that 0. And then, so what would, if x is 0 plus 1 minus 2, that would be -3. And then to get to the next underneath would be 3. So if we did that, which gets us to 4, plug that into your original, and you've got -4. So now go ahead and plot your points. Now notice, in this case, you've got, it's flipped and it's going this direction. And then remember, we said we have a negative, so that's why it's flipped that way. So your anchor point is where it begins, or where it's your, think of it like a vertex, it's where it begins. It's your h and your k. And domain is your h to infinity. So remember, that's still going to be your x's. So from here on, so that's where your domain is. Your range, though, now, since we're going down, your range is actually going to be from here down. So that's why it's -2 to -infinity. All right, you're going to try that one. And then that is how you do square root graphs.